Well, who would have thought there'd been a part 3? If the last one made me think of kind of albums, this one kind of makes me think of 1970s progressive rock albums. This is kind of the gatefold double album with side 3 on it as well as sides 1 and 2. If you don't know what I'm talking about, think of it as being like a kind of DVD boxed set or something like that. So I was finishing off there by showing you how to do a graph. I think this is quite nice because graphs, we've seen that plots can be useful, or graphs can be useful in interpreting data. They can also be a nice way of presenting data. The graphs that SPSS does through ANOVA, the little line diagrams, aren't that nice. Probably a better way of doing prettier graphs is to use the graphs function here. So we go to graphs, and then legacy docs is where the kind of off the peg graphs are located. You want to do a bar chart, for example. You get presented with this. Now, the rule of thumb here is that if you've got a between subjects design with more than 2 independent variables, so between more than 2, which we've got here, we want to go with clustered. Simple is fine for within participants, as we'll see, or when you've got, you're comparing 2 means, doing a t-test, but you want to cluster them because you've got more than 2 IVs. And we want to click on summaries for groups of cases, not summaries of separate variables. So groups of cases clustered, and we go to define, and this comes up with our list of variables here, our IVs and DVs. We want our bars to represent session hours, so how high the bar is, it represents how many hours each participant was in therapy for. So we click on, we don't want number of cases, we want the mean. So other statistic, e.g. mean. So we put session hours in there we go. And it automatically defaults to mean. If you wanted to change that to something else, for example, let's say you'd done a non-parametric analysis, the data was skewed, and the mean isn't a very good measure of the typical person, then you can come in here and you can ask for medians or whatever, but mean is normally good enough in ANOVA. And then simply we want to cluster, want these to be a category axis. Let's get up to that gender, and we can define clusters by therapy. Now, which way around you do these is up to you. You could have therapy as a category axis. You could define clusters by gender. What I suggest here is that you have a look at the graph, see which makes best sense to you, see which kind of graph. So do each of the 2 graphs. Having gender as a category axis as here, and then do another graph with therapy as a category axis, defining cluster by gender, in order to see which makes more sense to you and which best communicates the point you wish to make if you're doing this, say, in a lab report or in a dissertation. We can also get other information here. We can display error bars, which are handy. So let's just standard error. We can do standard deviation. Let's just stick at standard error. Or confidence intervals, whatever you want to use. Again, it's up to you. And then that's that done. We've got everything in there, and we click OK. And oh, what's happened here? Something very bad has happened here. I've committed the cardinal sin of SPSS. Can anybody think what the cardinal sin of SPSS may be that I've committed here? It's called not unsplitting the file when you've split it. So if ever you get this kind of arrangement, or you're trying to do an analysis and for some reason it's not doing them all together, it's doing them separately, chances are it's because you've got to unsplit the file. This was of course deliberate because this is a very common error, and I wanted to show you how common these errors are, and I also wanted you to see that I'm human as well. So let's get rid of that, and then let's say analyze all cases, do not compare groups. We don't need to do that, but I'm doing that just to make doubly sure that I don't get egg on my face yet again. Let's go back to graphs and do it again. We don't need to do it all again because everything will have been saved. Hopefully, there we go. What we get is a nice graph here which shows the interaction. You can see that males are doing better on cognitive, females doing better on this, and for females it's the other way around. And we've got the error bars here. Now, I mentioned Levine's test earlier on, which again, I'm still not going to tell you how to do that because it's slightly fiddly sometimes. May require you doing a non-parametric test, but I think usually we can kind of get away with it. But remember that I said that one of the assumptions of ANOVA is that variances for each of the groups is approximately the same. What you can see here is that the variances, or in this case the standard error, which is related to variance, are comparatively low for males undergoing PCT, low for males undergoing CBT or cognitive therapy. A bit bigger there for females undergoing cognitive therapy, but really quite big for females. So first of all, there's more variation in the female responses. Females seem more variable in their response to therapy. Again, these data aren't real, so don't go away thinking this is a truth. Usually it turns out for many psychological variables, males are more variable than females. So male IQ tends to be more variable than IQ is for females, so females tend to be more variable than males. So this is not a general rule, this is just some numbers. But you can actually tell quite a lot. You can, I think this is a good thing to tell yourself these stories. It seems that females are quite variable, so females are responding more variably to the treatment than males. And almost certainly this female variation here is why Levine's test was significant upstream. Okay, so just to summarize what we did there, start at the very beginning. When you're confronted with the data, first thing to think, what kind of design is it? Is it between? In which case I'll use coding variables. Is it within? In which case I don't use coding variables, you just enter each variable in a column. Or is it mixed? In which case you will have a coding variable for the between participants variable, and you would have the other variable, other levels of the variable in columns. So that's the first thing. How do you set the data up? Second thing is, make sure you think how many variables. Don't think about conditions, think of variables. 2 variables, each of which has 2 levels, 2 by 2 design. That means we're going to need 2 columns with a coding variable for each of the 2 levels in each. That's what we did when we set up. Very important. First thing you do once you've set your data up is test for outliers. Any outliers, deal with them, then test for skewness. If that's okay, once you've done that, then you can proceed. If it's not okay, if the data is skewed, you may consider using a non-parametric version of ANOVA, more of which later, or you may consider doing some kind of transformation on the data to reduce the skew. Talked about that in the lecture. You can do like reciprocal transforms, or you can do logarithmic transforms, which are designed to kind of squish negative or positive skew and make it more normal. Once you can do the ANOVA, ask for tests of the quality of variance, ask for tests of effect size, ask for tests of ask for power if you want power. We didn't cover power here, but that might be something you wish to look at. Once you've done the ANOVA, ask for plots. Once you've done the ANOVA and got the plots, look at the plots. Focus on the plots first. What story do the graphs need to be saying? You can do the plots through ANOVA as we did in this one, or as we did at the end in this particular in part 3 here, we actually got some bar charts up. If you don't like bar charts, then perfectly okay to do line drawings if that's what you want to do. Multiple cases, again, same thing as before. Other statistic, therapy sessions, gender, you can do a line graph here, which basically shows us what we saw in the ANOVA plot. Up to you. But look at the plot first. What's going on? Tell yourself a story. What's a take-home message? Work it out in your head. Once you've worked it out, go back to the ANOVA, make sense of the ANOVA. If you get significant main effects, significant interactions, then you need to do pairwise comparisons using the t-test, which involves you unfortunately splitting a file. Remember to unsplit the file if you plan on doing anything else with the data. Okay, very important point. So that's basically how you interpret the ANOVA. If you find that your ANOVA is non-significant straight away through, no main effects, no interactions, then you just report the ANOVA as being non-significant in all 3 cases, and there's no need to go on to do any pairwise comparisons. In order to do pairwise comparisons, the ANOVA needs to have something significant. If not, you stop at that point. Okay, thank you for listening to this extended broadcast, and no doubt I will have other podcasts and screencasts on other parts of ANOVA coming up soon. Thank you.